configure our base receiver that we're going to use for the rest of the jobs that we do today, first I'm going to plug the antenna connector into the antenna hole on the side of the receiver here. Now I need to be careful. Right underneath the antenna connector is the AC adapter hole. And if we plug the antenna connector into the AC adapter hole, it'll bend the center wire on the antenna connector over, and we'll be done for the day. The next thing I'm going to do, because I'm running a base and it's going to be here for quite some time, I'm going to set up an external battery so that the battery in my base receiver doesn't run down while I'm out using my rover. The other advantage of this is when I come back, this motorcycle battery that's on the ground here will actually charge my base receiver. So when I come back at the end of the day, the base receiver will be 100% charged. I can save some time and never have to charge a battery by exchanging my base and rover every day, because every day at the end of the day my base will be fully charged, the rover will be run down. The next day I can make the rover the base and charge it while I'm out working, and that way I'll never have to charge a ProMark 3. Now the first thing that we need to do when we come into the ProMark 3 is go into the settings screen and go to date time. We want to make sure that the date and time are correct. In this case, I'm not in the Pacific time zone. I'm going to change it to Mountain time zone. I'll press apply, and 11:36:05, that's the right time. It's Tuesday, September 2008. I'll press OK. If you go into that screen and the receiver does not have the right date and time, don't change it. It's a GPS receiver. As soon as it gets the signal from the satellites, it'll set the internal time in the receiver and we'll be good to go. Just get out of the date time routine, wait a minute or two, come back in and check and make sure that it's right. Also in this screen, we might change the backlight control. I've got the backlight control turned up all the way so that you can see this with the camera that's above me. Under display, I've also changed my backlight to never turn off. I'd recommend that you check this box and set the time to say 15 seconds. That will turn the backlight off on the display, and typically that's a good idea because it keeps people who are walking by, looky-loos, from messing with the receiver. It just looks like it's turned off. Well, I've checked the date and time and they're correct. I'm going to close the settings screen and I'm going to start the survey program. Now I can double click on the survey program, or I can just click on it once and press the enter key and it'll load it. I find clicking once and pressing the enter key to be easier. Surveying will start here. We need to wait until it shows that it's got carrier phase on 5 or more satellites. And you'll see on the screen here right now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 satellites and 1 SBAS satellite. So I'm good to survey at this point. Except that this is the first job of a new project. And so I want to delete everything that's on the receiver. To do that, I'm going to press the menu key, and then I'm going to go to the File Manager, and I'm going to click on Delete All. This deletes all of the jobs that are in the receiver. That way I'm not going to be confused with jobs that are from, or with files that are from 3 or 4 months ago. The next thing I'm going to do is go to Menu, and then Setup. I'm going to go down here to the bottom to Clear Memory, and I'm going to click on All. It'll ask me clear all memory. I'll click on Yes. And the program will actually exit and then come back into the surveying program. This resets everything in the survey program to the factory defaults. I like to do that because I know that everything's set the same way every time I start a job. I'm going to use English today, and then it says I need to press enter to agree to the terms of using it. I do that and I'm back to this screen. Now before I take off and run, I need to go back to the setup screen. I need to go to storage and make sure that it's internal memory. I don't have an SD card in this receiver. I've got one in my pocket, and at the end of the job I'll copy the data from the receiver to the SD card. So if I click on storage and then internal memory, I'm sure that it's going to be logged into internal memory. It comes up and says data will be logged to internal memory. Next I need to go to receiver ID. Now if we have the same receiver ID in both our base and our rover, we will generate files that have exactly the same file name. So we won't be able to keep those files in the same folder when we go to post-process. That's really bad. I'm going to call the receiver, the base receiver, I'm cleverly going to call it BASE, or base. The only other thing that I need to set is the antenna type. It's the third item in here. This is a NAP 100 antenna. I'll click on NAP 100 and I'm good to go now. If I press the escape key, I'll come back to the main menu. From this main menu, I can press the nav key and I can see a map of where I'm at, and you can go through a bunch of standard GPS screens. These screens don't really matter. You can turn them off in the setup mode if you want. Since I'm always clearing the memory and returning to factory setup, they're always there. I just don't worry about it. I'm ready to start logging static data now at the base, and to do that, all I do is press the rubber log button at the bottom. I'm going to give it a site ID, and I'm going to call it 1000 for my site ID. For my description, I'm going to call it the mark name, which is 1N2E. 1N2E. The antenna height, I'll cover in a second. The survey mode is static. The antenna height is going to be a slant, and I'm going to set my recording data interval to 1 second. Now, you'll notice that I can't directly measure the height of the receiving antenna. The antenna reference point is the bottom of the brass disc at the bottom of the antenna here, but I've got all this tri-rack and tripod head in the way. So to measure that, I'm going to use the nifty tape measure that comes in the kit, and you'll notice this tape measure is pretty dangerous. First off, every time you pick it up, it's going to poke a hole in the palm of your hand. The second thing you need to note is that the first 7 centimeters of this tape measure are missing. That's because from the front of the tape measure to the end of the point here is exactly 7 centimeters. So this tape measure direct reads from the underside of the hook to the end of the point. On the antenna up here, you'll find that there's a bunch of little nibs on the very top. And so I can take the antenna, click it on the nib, and make a slant measurement. I'll bring the tape measure up here so that you can see it. My height is exactly 1.552, and those are in meters. I'm going to change this, and my antenna height is 0.1552. Now I like to always measure my instrument heights twice, and the reason I like to do that is because I mess them up about 50% of the time. So I'll actually pull the tape off, reset it, and measure again. If I had a field book with me, I would actually write down the instrument height for this measurement in feeters. So I'd write down 1.552 and 4 or 5 feet. See, it's 5.09. I'd write both those numbers down in my field book so that if I wrote one of them down in the receiver, I can fix it. Now, anything that you set up in the receiver here, pretty much, other than the raw data interval, we can change back in the office in GNSS Solutions when we post-process. I'm not going to check the control point because I'm not going to initialize on this location again. So to review, I've set in a site ID, 1000, which is typically what I use for a base. I've chosen the static survey mode. I've put in a site description that's the name of the mark that I'm occupying. I've entered the antenna height in meters. If I wanted to enter it in feet, I could also do that. I've entered the antenna height, and I've checked it twice. I've set the antenna height type to slant, and I've set my raw data interval to 1 second. Now to start recording data, I just push the OK button, and I'm good to go. This display over here, elapsed, will show me how much time has elapsed since I started recording this session. I can see the number of satellites is 11, and the PDOP is quite good, 1.5. The file name up here, base A08267. Base is the name of the receiver. A indicates that it's the first file that I've recorded today. The second file will have a file name of B. 08 is the year, and 267 is the Julian date of the year. So we're at the 267th day of the year at this point. And after a while, the observation range will start to increase. It doesn't really mean much for your base receiver. One other note, when you set up your base receiver, you need to set your base in the absolute best location that you'll find on your job. It doesn't necessarily need to be on a control point. I've set the base up on a control point so that we can verify that I can generate a real position for this base receiver. We can verify it with the point that we're over. But your receiver, your base receiver, needs to be able to see every single satellite that's possible. So in this case, we've set our base up at the highest point in our job, and there's absolutely no obstructions in any direction. The reason we need to do this is that our rover is going to assume that the base can always see every single GPS satellite that the rover sees. The base and the rover in this configuration don't talk to each other, so the assumption is that the base can see every single satellite that the rover can see all of the time. Where our base is set up now, we're ready to do a initialization on our rover and record some data.